especially about the security models for modern healthcare startups, which is really crucial, especially in the age of AI, where trust is the currency and zero trust is your insurance policy. Here you can see our speakers for our today's webinar. My name is Nazari. I'm Senior Growth Partner. I'll be leading this webinar. And Roman is our lead DevOps engineer, who will be our main speaker and will be able to cover any technical questions that may arise on your end during the webinar. So don't hesitate to reach via the chat. If you have any questions, we'll be more than happy to cover them. As we can see, people are still joining. So we will give another minute for them to join and we will be starting. Meanwhile, I would ask you to share via chat where are you guys joining from. We always love to know the locations, the time zones which are involved in our webinar. Thank you. Nice, I see Spain is here. Germany, good. So anyone from the USA? Cape Town, good, good. Thank you for sharing. So I see that there are some more people already joined. I guess we may start. Who is joining right now, just feel free to ask any questions via chat. We will be more than glad to cover them during the webinar. Of course, if you're talking about our agenda for the meeting today, for the webinar, we will be talking about the new frontier, the AI in healthcare, about the zero trust, why it's crucial nowadays to be implemented in the healthcare. The sensitive patient data like HIPAA compliance and GDPR readiness. Of course, we will talk about the risks, understanding how it could be implemented in terms of protection to make sure your sensitive data or the patient data is protected from illegal activities like fraudulent activities, data breaches, or data leaks, and going on. Of course, we will discuss some best practices and strategies that we use and what we suggest and other businesses to use. And we will go through some vulnerabilities, some fundamental components for the security and AI hosting. Following, we will talk about the human factor, which is always taking place because there is nothing which can be done without the human interaction yet. Of course, we will touch the CI/CD pipelines, as well as the run pod, the healthcare AWS, and we will walk through some infrastructure as a code and compliance as a code examples, following with the real world case study with the healthcare startup, where you can see how it was implemented with the real world scenarios. After that, of course, we'll have the Q&A session where you'll be able to ask any questions that may arise during our webinar, and Roman will be more than glad to cover those. So now I would love to give the floor to Roman. We can start. Please go ahead.
So hello everyone. I'm glad to be here, and let's start some of our work. Artificial intelligence is no longer just a buzzword in healthcare. It's here and transforming how we deliver care. We're seeing predictive diagnostics that can spot disease earlier than human doctors, sometimes before symptoms even appear. We have a personalized medicine where treatments are tailored to a patient's genetics and lifestyle. And we are seeing intelligent remote monitoring with sensors that can alert core teams to critical events before they become life-threatening. But with this opportunity comes challenge. Patient health information, or PHI, is among the most valuable and sensitive type of data in the world. It's a prime target for attackers because it's worth a lot on the dark web and can be exploited for fraud. A breach doesn't just mean fines and compliances issue. It means a loss of patient trust, which is devastating for any healthcare organization. At the same time, the old security approach, which is called castle and moat, just don't work anymore. Data is everywhere now in the cloud, on connected devices, in APIs, and AI systems rely on this disturbed data to function, but it makes the attack surface much larger. That's why we need the zero trust approach to keep both innovation and security in balance. Let's go forward. Zero Trust is a modern security model built on a simple but powerful principle. Never trust, always verify. Traditionally, if something was inside the network perimeter, it was assumed to be safe. But that no longer works when data and AI models live across clouds, APIs, and devices. And when attackers can compromise inside or third-party tools. Zero trust flips the mindset. Uh, every single request, whatever it's an app calling in the AI engine or a modern model accessing training data or user logging in, must be authenticated, authorized, and continuously validated. We encrypt sensitive data artifacts, training datasets, and inference calls. We watch for anomalies that might indicate misuse or attacks. Importantly, zero trust in AI isn't just about the network. It's about protecting the models, the data, and the workflow that power them up. That means building security into how AI model are stored, trained, deployed, and used. Not just into firewalls or VPNs. Let's go ahead. Um, Healthcare is one of the most attractive targets for cyber criminals. In fact, over 90% of healthcare organizations have faced major breaches in recent years, and many of those incidents directly disturbed patient care. Traditional defense just don't cut it anymore because our systems now stretch across clouds, cloud platforms, workers, AI services, and countless third-party integrations. You can't rely on network location to decide where is safe. Zero Trust enforces continuous verification. It checks user identity, device health, and context for every access request. That means attackers can simply get inside the network and roam free. For AI, this is especially critical because these systems rely on large, valuable datasets and complex models, both of which are vulnerable to adversarial inputs, data poisoning, and model theft. Zero Trust helps us secure them while while also meeting regulations like HIPAA and GDPR, enforcing least privilege access and creating audit trails for compliance. Ultimately, it reduces the risk of ransomware, inside threats, and third-party breaches, which is keeping patient data safe and ensuring that healthcare delivery can continue even if there is an attempt to attack. Okay, let's go ahead.
So, dear visitors, as we understand, zero trust is crucial for the implementation of the artificial intelligence in nowadays healthcare domain. We would love to ask the question, have you guys already implemented a zero trust approach, or maybe you're considering of doing so in the near future? Please respond to that question via chat. Thank you.
So let me answer on that question. Zero trust is zero trust matters in healthcare AI because patient data is too sensitive to rely on old security models. It makes secure every user and system is itself. So data stays safe and trustworthy. Let's go ahead. In healthcare, data isn't just information, it's someone's life. Two major regulations govern how we handle patient data. In the USA, this is HIPAA, which sets strict safeguards for storing, transmitting, and accessing protected health information. In the Europe, it is GDPR, and it requires a lawful basis for data use, limits how much data we collect, and demands explicit patient consent. Failing to comply isn't just about fines, although those can reach millions of dollars or euros. It's about reputation and trust. A single breach or a compliance failure can set a young healthcare startup back in years. That's why we use compliance as code approach. Instead of treating HIPAA and GDPR as checklists, we embedded them directly into the AI and ML pipeline. Automated quality gates verify consent, ensure lawful data use, and stop non-compliant releases before they ever reach production. We identify patient dataset before training models, and we encrypt data at rest, in transit, and even during use. Every stage for ingestion or to training to deployment get automated checks for fairness, consent, and auditability. This approach makes compliance scalable and repeatable, which is crucial for startups moving fast in AI development. Let's go forward. When we host AI models and services, we are exposing an entirely new set of risks. First is data privacy. We're working with highly sensitive health data, and if APIs or storage aren't properly protected, it can leak. Then there is an insecure API and interfaces. AI systems depends on APIs to communicate between applications, models, and data layers. Weak authentication or pure login here is a golden opportunity for attackers. AI also brings a new attack vector like data poisoning, where malicious inputs subtly corrupt training data and model theft. An attacker can replicate or steal your intellectual property. Finally, there is often a lack of transparency in AI operations. If we don't know how models are behaving, we can spot malicious manipulations or unexpected drift. These risks mean we have to design or our AI host an environment with security in mind for day one, but not as an afterthought somewhere in the end. Let's go forward. So how do we defend against these threats? Let's look at some key strategies. First, we protect against data poisoning by validating and filtering all training and streaming inputs, tracking the provenance, and using clean, verified datasets. To prevent model theft and intellectual property loss, we encrypt models, use secure storage, and apply fine-grained access control, so only authorized processes can touch them. We defend against adversarial evasion attacks, where tiny changes to inputs trick model into making wrong predictions. By retraining models with adversarial examples, using anomaly detection and the modeling potential threats early. APIs need special attention. We secure them with strong authentication, rate limiting, and penetration testing. Gateways help control exposure and logging. Uh, Taken together, these practices create a layered defense around AI applications, from the data they rely on and to the APIs they expose. So let's go ahead.
Dear audience, take into the look that the security audits nowadays are supposed to be done on the regular basis, or when you take a look to your own pipeline and to your own processes, when was the last time you have reviewed your AI or software for potential security gaps? We would love to hear your thoughts via chat. Thank you.
Mm, I think I can answer on this question from my side. Most startups don't run audits really often enough. Even a simple review every few months can catch issue earlier and save you from bigger security risk down the road. Um, Based on my experience and my personal recommendation, adding these steps to your priority list is crucial for any company which is dealing with AIs and some APIs and examples which I just told to you guys. Let's go ahead. Um, Before we talk solutions, let's map the threat surface specific for to AI. First, data poisoning. If attackers slip malicious records into training or streaming data, the model learns the wrong patterns and produces harmful outputs. This often looks like subtle drift, so we need strict input, or some kind of validate input, and provenance tracking and clean data pipelines. Second, intellectual property and model theft. Models capture hard-won, known how, and sometimes sensitive statistical signals. If weights or artifacts leak, you lose competitive advantage and risk privacy exposure. We prevent this with encryption, segmented storage, and least privilege access to model artifacts. Third, adversarial evasion attacks. Tiny, careful crafted changes to input can cause confident but wrong predictions. We count this with adversarial training, anomaly detection, and red training to understand how models fail. And finally, API security weakness. AI doesn't live in a vacuum, as we know, and it is called through APIs by apps, services, and partners, and whatever can call. Weak aloof, poor login, or noisy rate limits can turn APIs into wide open door. Gateways, robust out, and routine tests are crucial for preventing these breaches. Taken together, these four areas define the core AI-specific risk landscape, which we must design against. Let's go ahead. Now let's zoom out and look at the overall vulnerability landscape when hosting AI. Insider threats remain one of the biggest risks. Employers or contractors, even unintentionally, can expose or misuse sensitive data. Third party and supply chain risk are another challenge. We rely on cloud providers, data vendors, and AI tools, but any weak link in those can compromise the whole system. Underlying infrastructure vulnerabilities, unpatched servers, weak configurations can become entry points for attackers. And finally, authentication and authorization gaps. Weak credentials, overly broad access, or a missing multi-factor authentication open the door to manipulation. In the age of AI, trust itself can be valuable, and that's why zero trust with its never trust, always verify philosophy is so critical to modern AI hosting. Let's go ahead. Um, Now let's turn that threat map into a concrete security baseline for AI hosting. Comprehensive data encryption is step one. Encrypt data at rest, in transit, and where feasible in use. That way, even if an attacker intercepts something, if not usable, MFA and rebug enforce the principle of least privilege. Every action from pulling a model to invoking an inference endpoint requires strong identity checks and tightly scoped roles. Secure AI model development and deployment means these three things in practice. Secure coding to prevent data leaks and common vulnerabilities. Regular patching of runtimes, drivers, and dependencies. and containerization to isolate model and limit blast radius if something breaks. Continuous monitoring and anomaly detection give us visibility. We watch logs, metrics, and model behavior so we can spot drift, abuse, or compromise early and act fast. And finally, compliance with regulatory standards. We build in privacy controls and maintain audit trails for every access and change. That's how we satisfy HIPAA with GDPR and, more importantly, maintain patient trust. Those fundamentals create a repeatable foundation for that scale with your product without slowing your team down. Let's go ahead. No matter how advanced our security system are, people remain the weakest link. In healthcare, staff often work under high stress and multitasking pressure. That makes them more likely to click on phishing links, reuse weak passwords, or accidental send sensitive data to the wrong person or service. We also see insider threats, sometimes malicious, but often just by accident. Misconfigured security settings, unpatched software, or poor data handling practices can create huge openings for hackers. And many employers simply aren't aware of modern security risks, especially when AI systems are involved. This is why zero trust isn't just about technology, it's about culture. We need targeted training, clear accountability, and constant monitoring of how humans interact with AI systems. Only then can zero trust truly reduce the human attack surface. Ooh, let's go forward.
So when we are talking about AI, someone is still working with it, right? So we are talking about the human factor, about the interaction with AI. So when you take a look to your current processes, how do you currently address the human factor in security? For instance, something like phishing risks, weak passwords, insider threats. For instance, when you're building or scaling your healthcare AI systems. Please share your thoughts via chat. Thank you.
So, my answer on this question will be that human errors are often the weakest link in security. Simple steps like regular staff training, strong password policies, and monitoring for unusual behavior can make a huge difference in keeping your AI system and basically the whole system safe and guarded. Let's go ahead. So, how do we strengthen the human side of zero trust? First, we deliver target security and AI awareness training. Tailored programs that explain how AI works, highlight social engineering risks, and cover healthcare specific cyber threats. We reinforce zero trust principles in daily workflows, making continuous verification a normal part of using AI system. We encourage human AI collaboration and oversight, People should actively monitor AI outputs and intervene them when they see anomalies or ethical issue. We set clear accountability and ethical frameworks so everyone knows who is responsible for AI decision and data handling. And finally, we address stress and fatigue to design technology and processes that reduce cognitive overload. A calmer, well-supported workforce makes fewer security mistakes. With these steps, we turn the human factor from a vulnerability into a strength. Let's go ahead. For healthcare startups building AI products, the CI/CD pipeline is a critical part of Zero Trust. We use private build runners that spin up formal VMs or containers inside a secure VPC, run the build, and then terminate, leaving no persistent attack surface. Every commit and model is signed and tracked with a software bill of materials so we can deploy trusted builds. Secrets are never stored in plain text. Instead, we encrypt and validate them. And inject short-lived tokens securely at build time. The pipeline is segmented by environment with strict IAM roles, airbag, and multi-factor authentication. So automated scans check code, dependencies, containers, and even AI models for vulnerabilities or data drift. We keep immutable audit logs of every build and deployment, and we integrate real-time monitoring and incident response tools. Finally, we enforce policy as code, automated approval gates, and compliance checks that blocks non-compliant releases before they even reach production. Let's go forward. When we bring Zero Trust to AWS, we focus on three main areas: data protection, model and API security, and detection with response. For data integrity, we use encrypted volumes with checksums, offload PHI to HIPAA compliant storage, and validate datasets before model load. We use confidential computing to isolate sensitive model training and inference workloads. And we secure containers with egress restrictions, non-root users, and hard-ended profiles like seccomp or AppArmor or etc. Model protection is key. We keep model weights separate from code with read-only mounts, sign Docker images, and rotate inference tokens regularly. On the detection side, we interrogate tools like Trivi or Sneak into CICD for vulnerability scanning, export logs and GPU metrics to monitoring systems, and run tools like Falco for real-time runtime protection. This combination makes AWS a strong foundation for compliant, and cost-effective AI hosting. Let's go ahead. Let's look at RunPod, a popular GPU cloud for AI workloads, and how we can apply zero trust principles there. First, we treat infrastructure as ephemeral. Each training or inference jobs runs in a temporary container or pod, isolated inside private subnets and VPC endpoints. Once the task is completed, the environment is destroyed and removing persistence that attackers could exploit. We enforce least privilege IAM roles and use encryption by default for both data in motion and at rest. Model weights and sensitive datasets stay separate and encrypted, only accessible to the job when it needs them. We interrogate confidential computing where possible to protect sensitive inferences and training workloads, even from the host system. And finally, we maintain immutable audit logs of every action, provisioning, data access, and deployment. This makes forcings and compliance much simpler while discouraging misuse. The result is that even in a flexible GPU on demand environment like RunPod, we can maintain strong zero trust security without slowing down development. Let's go ahead. Of course, adopting AI securely isn't simple. There are real world challenges. First, data quality and bias. AI systems are only as good as data they're trained on, and the healthcare data can be messy, biased, or incomplete. Second, the skill gap. Few professionals deeply understand both AI and healthcare cybersecurity, which is making hiring and training tough. Third, integration with legacy systems. Many hospitals and clinics still run older technology that doesn't easily connect to modern AI platforms. We also faced ethical considerations, especially around patient privacy, consent, and explainability. When there are costs and resource allocation, building secure AI pipeline requires upfront investment in tech and training, which is hard for lean startups. Finally, regulatory complexity. Keeping up the HIPAA and GDPR and evolving AI-specific rules to that takes continuous effort. These challenges are real, but with right strategy, zero trust, and automation can help overcome them. Let's go ahead.
Dear guests, when we are talking about the implementation of AI for healthcare cybersecurity, it's not some common and easy thing, right? We are talking about something that may have some challenges for implementing from different points of view. So we've got the question to you. What is the biggest challenge you have faced connecting AI tools to your healthcare software? We would love to hear your thoughts via chat. Thank you.
Thanks, but let me say my answer to that question, maybe a comment. That's a common challenge nowadays. Many healthcare systems struggle because legacy software wasn't built with AI in mind. Careful planning, APIs, and gradual integration can help AI tools work smoothly without disturbing existing workflows. Let's go ahead. Infrastructure as code and compliance as code are some of the most powerful tools for making zero trust scalable. With infrastructure as a code tools, tools like Terraform, AWS SDK, or Pulumi, or whatever, we encode guardrails, least privilege IAM roles, encryption everywhere, private subnets, and VPC endpoints. If something is misconfigured, the pipeline fails before it's deployed. With compliance as code, we embedded HIPAA and GDPR checks directly into CI/CD using policy engineers like OPA or Sentimental. For example, we can block a deployment if bucket is public or it was changed or misconfigured, or stop a model release if constant metadata is missing or misconfigured. This approach doesn't just make us secure, it makes compliance automatic, consistent, and auditable, which is vital for healthcare startups that want to move fast without breaking trust or regulations. Let's go ahead. Let me share a practical story from a digital health startup which we worked with. They were building an AI-powered platform for patient care and needed to pass HIPAA audits while moving fast. We applied zero trust in several ways. Data encryption everywhere using AWS KMS or PHI at rest and TLS 1.3 in transit. Least privilege IAM with just-in-time credentials, ephemeral CI/CD runners that start, build, and terminate inside isolated VPC containers, model security, which is signing every model with cosign before deployment, compliance as code with Terraform and OPA rules that blocked non-compliant infrastructure or datasets. In just 6 months, they reduced unauthorized PHI access risk by 70%, eliminated critical misconfiguration in production, and passed a HIPAA security audit with no major findings. Ephemeral runners also blocked attacker persistent attempts and cut cloud cost. Automated checks cut approximately 35% of misconfiguration post-deploy, making the platform far safer and cheaper to run. Let's go ahead. We didn't stop there. We added artifact integrity with signed models, SBOMs, and encrypted weight storage. Policy as code with CI gates that blocked misconfiguration of or drift before deploy. Continuous monitoring using CloudTrail, GuardDuty, and SageMaker Monitor. Incident runbooks with automated response to PHI leaks, credential compromise, or model tampering. Training and awareness programs for developers on secure coding and zero trust practices. The results were quite a bit powerful, I would say. Zero unverified artifacts reach production. Supply chain issue were stopped before release. From 15 to 20 non-compliant releases were blocked automatically, saving around 20 plus engineering hours each month. Detection of anomalies become 60% faster, which is cutting false negatives and improving containment. Automated incident response cut mean time to respond to PHI issue by half, and developer security mistakes dropped by over 30% as zero trust habits become natural. This wins shows how zero trust doesn't just protect data, it makes teams faster, leaner, and more confident. Let's go ahead. Um, to wrap up the case study, here's what the approach delivered in total. Using zero trust with compliance as code, formal CI/CD runnels, signed models, and centralized monitoring, the startup shorted ML release cycle by up to 25%, which is getting feature to market faster. Cut cloud cost by 20% through better resource control and FinOps dashboard. Achieved built-in HIPAA GDPR compliance instead of scrambling them at the last minute of the last deploy or post-deploy. Eliminated raw PHI exposure and maintained strong encryption everywhere. Also gained stakeholder trust with transparent KPIs and auditable pipelines. Business outcomes were clear. Approximately 70% lower risk of unauthorized PHI access, zero critical misconfiguration in productions, 20 plus hours per month saved through automated compliance, and 35% drop in infrastructure misconfigs thanks to infrastructure as a code enforcement. This is the power of combining AI innovation and solid zero trust foundations. Let's go ahead.
Dear audience, having this real world case study in front of you with this scenario, when you take a look to your current AI deployment process, how confident could you be that this process balances speed, cost, compliance, and security effectively? Please share your thoughts via chat. Thank you. Thank you, Mark. Thank you, Ben.
In my practice, many organizations struggle to balance all of these. Using automated compliance checks, zero practices, and cost monitoring can help speed up AI release while keeping data secure and meeting regulations. And there is a lot of more things which can impact and be the good outcome. So let's go ahead.
So it's time for our Q&A session, guys. Please don't hesitate to ask any questions that may arise during this webinar. Roman will be more than glad to cover those, maybe give you some insights, what could be helpful and implemented in your own business. Don't hesitate. Please use the chat to ask the questions. Thank you. Got the question from Dan, which is, we are a small healthcare startup without a dedicated security team. And the question is, what's the first step toward zero trust?
The small startup usually focus on identity and access control. Make sure every account, human or machine, uses strong authentication, uh, preferably MFA if possible, and least privileged roles. Then encrypt sensitive data at rest and in transit. From there, you can add automated policy checks and formal CI/CD runners over time. The key is to start with strong access boundaries and expand them gradually. So after that comes even more challenges and the more advanced ways to secure your infrastructure with the help of basic team without needed of some specific team.
Thank you, Roman. Now we can see that Mark from Germany is asking about how do you protect AI models from theft or reverse engineering?
That's quite a good question. We store model weights separately from code and encrypt them. Access is controlled with least privileged IAM role and short-lived tokens or in-time access. We also sign models and containers, so only verified artifacts or are deployed. If a model must be shared, we can use um, hmm, we can use which applications we can use. We can use delegations or obfuscations or distillation to reduce leakage. And what else? Basically, there is a lot of what we can do, but this is basics. And of course, runtime monitoring helps detect unusual access that might indicate model extraction attempts or theft. And of course, don't forget to secure your registry and do not expose it. And always use some one-time gain tokens if you need to access it from third party or something like that with automation.
Thank you, Roman. Maybe you guys have any other questions? Got the question from Dan. Zero trust sounds expensive. How can startups keep costs reasonable?
Um, to be honest, it's a fair concern, and in my practice, this is one of the most common or popular question or problem with which we're facing while working with startups. The trick is to use cloud native security features which you are already paid for, like AWS IAM, VPC endpoints, KMS encryption, and WAF and Guard Duty, some monitors and Shield, and combine them with open source tools like OPA or I don't know, some API tokens configuration, or basically the list is too big, but OPA is most popular tool. And of course, policy as code. Oh, I remembered Trivi, one of the tools. And altogether, with combination of services which you already paid for and these open source tools, you can use them for vulnerability scanning each time, or time to time, or always up and running scans, which can help you to not run in big months cost, but to have some visible and controlled infrastructure. Also, ephemeral runners can actually reduce long-term costs because they spin down after use and lower your attack surface. Zero trust doesn't have to mean enterprise size budgets or specific allocated teams specifically for this task. It can be done already with it can be done with a team which you already have. Just research what do you have at this moment of time, and research the programs or ways for which you are already paying, and start using them. And after that, just combine or add some open source or some low paid free tools which will combine in very strong output.
Thanks, Raman. Guys, please go ahead. One more question from Mark. What's the best way to handle secrets in an AI pipeline?
Um, Avoid storing secrets in code or plain environment variables. Use validating solutions like AWS Secrets Manager, HashiCorp Valued, or SSM Parameter Store, or self-configured secret service. Inject short-lived tokens at build or runtime instead of keeping long-term keys. Rotate credentials frequently and enforce MFA where it is possible. Also, this approach reduces the blast of radius if something leaks. Also, you can use desired runners. You can use private runners which can be configured with your cloud provider, and this runner is formal also, but it has access to all the AWS resources at the moment, and you can write a JSON or some config file from AWS side or cloud provider side to give to this runner, to this build, this type of run, or to this type of pipeline specific credentials or specific accesses only to specific resources. So it's one of the ways to handle secrets.
Thanks, Raman. Guys, we are reaching our timeline, but we are ready to answer some other questions, like two more, let's say. So please go ahead. We've got another question from Dan. How does compliance as a code help with HIPAA and GDPR audits?
Compliance as code turn security policies into automated checks in your CI/CD pipeline instead of manually verifying if a bucket is private or PHI is encrypted. The system blocks non-compliant deployments before they go live. For audits, you can show an immutable trail of policy, checks, and approvals. That saves time, reduces human error, and gives regulators clear evidence that that you control and enforce by default.
Thank you, Roman. Any other questions, guys? Got one more. We use third-party AI APIs. How much zero trust can we control?
Even when you rely on external AI services or external just services, you can apply zero trust on your side. Control how data is sent, encrypt it, and enforce strict authentications when coding those APIs. You can monitor a response for anomalies and log every request for auditing. You can't harden the infrastructure, but you can minimize expose and protect your patient data before it leaves your environment, or just the idea is that you're maximizing your protection and maximizing the most visible way to see where the threat came and where is the weakest point. So if something will happen, you will know 100, you will be 100% sure that it is or on your end or it is end of the third party. And if it's third party, that's different question and a different deal, business deal.
Thank you, Roman. Thank you all for all the questions you had today. If there are any left, please don't hesitate to get in touch with us through the LinkedIn, our website, or email, or some other channel. We'll be more than happy to cover those and give you some suggestions in terms of improvements. So you're always open to it. And we really thank you for your time for joining this webinar today. You have a great day or evening, and let's stay in touch. Thank you once again. Bye for now.
Thank you, everyone. Bye-bye. Have a nice time. If you need, just write us. We'll be waiting for your responses and willing to help you if needed and if we can.
Thank you. Enjoy.